GelSight is a soft, high-resolution tactile sensor that's as sensitive as human skin, and we've found many commercial applications where human hands have been used for doing quality inspection, assembly, and other tasks. We've been able to digitize those and create new value for our customers with this technology.
When my children were born, I thought I would be fascinated to watch how their visual system developed. But in fact, what happened is I got fascinated in the way their sense of touch was being used. Children, when they're small, are surprisingly capable of using their fingers to explore the world. And as I watched them, I wanted to understand that better. And I was trying to figure out, well, how could you build a sensor that could extract the kind of touch information that a baby gets with its fingers. And so I came up with this technology called GelSight. And what GelSight is you have a piece of rubber coated with a special coating and a camera behind it watching the surface and watching how the surface is deformed. And what that allows you to do is convert a mechanical signal, that is a touch signal, into a visual signal, and then you can interpret it with a computer. So that's a way to get touch information out of an artificial touch sensor. All right, so let's say this is your GelSight finger, and this is the soft rubber part, which is going to do the sensing. What you have is a special film covering the rubber. The rubber itself is clear, and then inside the finger is a camera and some lights. The lights are specially colored and specially placed to give good illumination. Then when an object comes and touches the surface, this membrane deforms, and the camera inside the finger can see what's happening. It can see how the surface is changing its shape and its orientation. And then by using computer vision techniques, we can extract a detailed picture of the 3D shape of exactly what's happening at the skin.
What we did was take that basic idea and turn it into a high-resolution surface measurement technology. And the YouTube videos we made about this caught the attention of the outside world. People started emailing, asking if we could measure airplane skins, human skin, and other applications, and that really led us to spin the company out and find commercial applications.
Human fingers have an acuity that's on the order of a couple of millimeters. So if you have two dots that are separated by a couple of millimeters and you touch your finger to them, you can tell that they're two distinct dots. But GelSight is much higher resolution than that. A GelSight sensor can resolve down to a few microns. So that's a huge difference in resolution.
Our current product, GelSight Mobile, is a handheld measurement tool that fits very nicely into inspection workflows in many industries. Here's how a customer might use it today. A quality inspector will look at a component and see a surface defect or a dent. The key question they have is, how deep is it? And am I able to repair this part, or do I have to scrap this part? That's where they can turn to our tool, and on the factory floor, within a few minutes, they get a measurement that says the depth of this scratch is 50 microns. They can decide at that point, yes, the part can be repaired, or no, it can't. Without our tool, they might have to make a replica, send that replica off to a measurement lab and wait at least 24 hours to get the result. Or they'd have to make a subjective decision and say, well, I think it looks too deep, maybe I need to scrap the part. So the ability to have a quick and accurate measurement has a lot of value in these applications. If you look at the use of robotics in a lot of industries today, they're used to do repetitive tasks that are very well controlled, moving a part from location A to location B over and over again, especially if the part is heavy or difficult for humans to do. But where human hands are still used is in the complex tasks, assembling components, building up substructures. And that's really the opportunity that GelSight can unlock. Combined with the advancements in vision and 3D systems with a tactile sensor and, of course, artificial intelligence algorithms, now we can start to really do these tasks where today they're limited to humans. And we've heard from many of our customers, big companies that have factories all over the world, they face labor shortages, a shortage of trained labor, a shortage of people who want to do these repetitive jobs. So the ability to automate them through advancements in tactile sensors and robotics, combined with other systems, really unlocks tremendous potential for them.
Well, I think MIT in general and CSAIL in particular are really great places if you're starting a company because there's a great ecosystem of people who know about companies. There's people who know about finance, people who know about business, people who know about how to develop a company. And it's a great community of people who really are interested in talking to each other and helping each other.